Hi everyone. In this lecture we're going to introduce you to a variety of statistics that are used to describe sample data. This will be the first of 3 different lectures that sort of walk through the 3 different sort of areas or categories that we typically approach when we're trying to describe a particular variable. So you'll notice this is for univariate statistics. You may recall that univariate statistics are used when we are analyzing or describing one particular variable. So that variable could be age, gender, race, political party, number of prior arrests, and any number of things. But if I have, observations from one variable from hundreds or thousands of respondents, how do I summarize and sort of briefly describe what I'm finding about that variable in order to share it with my audience? And the way that we typically think about going about that is sort of going through 3 different types of statistics. First, we want to summarize the variable using measures of central tendency or location. Second, we want to look at the variability or dispersion of the particular variable. And then finally, we want to use some statistics in order to summarize the shape or distribution of the variable. In this particular lecture, we're going to start off with the first category, measures of central tendency and location. And the reading that goes along with this particular lecture is chapter 2 from your course textbook. So let's go ahead and get started. So when we think about describing sample data and focusing on one variable, so univariate, here are the 3 sort of categories that we're going to walk through throughout the next few lectures. The first that we're going to focus on today is central tendency, otherwise known as location. So these are statistics that tell us about what the most common value or response might be for a variable. They are also the same types of statistics that we often hear when we talk about the average for a particular variable. In our next lecture, we're going to move on to measures of variability and dispersion. So we don't want to just know what the most typical value is or what the average value is. We also want to know what kind of variability or how much difference was there across the various responses to this variable. And that's where variability and dispersion come in. They capture sort of the variety of responses that you get from your particular research respondents. So they tell us about how different or diverse the responses are, as well as how spread out the values are. And then finally, we're going to talk about measures of shape or distribution. And many of you are probably familiar with what is known as the classic normal curve or the classic bell-shaped curve. And if you're not familiar, don't worry, we're going to be talking more about distributions in a few lectures. But these measures of shape are designed to ask the question, are the responses to a particular variable distributed in sort of a normal bell-shaped curve, or is there something what is known as skewness going on? And skewness occurs when there are either outliers or extreme values. And for most statistical purposes, the term outlier and extreme value can be used interchangeably. There are some technical differences, but we're not going to worry about that right now. So if you hear the word outlier or extreme value, this means like either a single or a small number of responses to that variable that are way out in one far extreme, either extremely low or extremely high. So in other words, not like the rest of the responses. And we'll talk about the importance of why we want to have measures of shape as well. So those are the 3 main categories that we think about when describing a single variable. Let's go ahead and launch into talking about central tendency and location. So in here, on this slide, what we have, as similar to what we've seen in a few other lectures, we start with a data example. So the chart on the right shows us a small data set. With the I column, we notice that there are 6 different cases or responses in this particular data set. And then we have X, Y, Z, and W, which are our 4 different variables. And then we just have some responses that I made up and threw in to create this data set. So let's quickly take a look at each one of these variables and see what they're measuring. So looking back over to the left, we see that X is number of prior arrests. So remember, thinking of level of measurement, number of prior arrests, and where the number means something and it tells us the whole story. This is a quantitative variable that would be at that interval or ratio level of measurement. So we see in our data, person number 1 had 8 prior arrests, person number 2 had 6, and so forth. Our second variable is going to be a nominal variable, a qualitative level variable, and that is current offense. And because it's nominal, the numbers don't have any true mathematical value. Rather, they just represent some nominal or qualitative category. So you can see for variable y, we have it set up where 1 equals violent offenses, 2 equals property offenses, 3 equals a drug offense, 4 equals other. And then you can see person number 1 had a violent offense, person number 2 had a violent offense, person number 3 had a drug offense, and so on. I then include variables z and w sort of to be sort of slight mirror images to variables x and y. And I included variables z and w in order to illustrate a few key components and advantages and disadvantages of different measures of central tendency that we'll get to. So variable z, as you can look, if you look at it, people or cases 1 through 5 look exactly like variable x. The only thing that is introduced to variable z is what we refer to as an outlier or an extreme value. So remember from the previous slide that an outlier or an extreme value is when you have a case or a small number of cases that are very different from the remainder of the cases. And you look at variable z, if you look at case number 6, you'll notice that person has a value of 28, right? They are nowhere near the rest of the other values. They are clearly an outlier. And we'll talk about the impact that having outliers can have on your measures of central tendency in just a moment. Finally, we have variable w, which is just sort of a parallel version of variable y, measuring current offense. But here, what we want to introduce is the idea of having multiple modes. And so what I've done in this one is, once again, cases 1 through 5 look just like they did with variable y. But for variable w, case number 6 has a value of 3 instead of what we saw with variable y with a value of 1. And we'll talk about the impact that that can have when trying to summarize that particular variable. So let's use these 4 variables, x, y, and z, and w, sorry, and then walk through 3 different types of measures of central tendency, talk about how to compute them, and also talk about the advantages and disadvantages of each one. So the first measure of central tendency or location we're going to cover is known as the mode. And so the mode, the definition is simply the most frequently occurring value or group for a particular variable. So how do I compute the mode? Well, there's really no fancy statistical formula. Really what we're trying to do for the mode is you just figure out which value or group appeared most frequently. So let's look at variable x. So we see an 8, a 6, a 4, a 5, etc. As we look through those particular values of variable x, we want to see, does one number seem to show up more often than any other number? And sure enough, if you look at those 6 observations for variable x, you'll notice that the value 4 shows up twice, where everything else only showed up once. So for variable x, the mode would be 4. Moving on to variable y, similar idea. We look through and we figure out which value shows up most often, and we see that the value 1 shows up most often. Therefore, for variable y, we get a mode of 1. But one thing we also probably want to consider about variable y is, because it was a qualitative variable at that nominal level of measurement, the number 1 doesn't really tell us anything with true meaning unless we know what 1 stands for. So that's why you'll notice here I include that the mode is 1, but also I indicate that that represents a violent offense. We look at variable z. And as I said, z and w were thrown into this data set to sort of illustrate some of the problems that might occur when using different measures of central tendency. So when we look at z, we go, okay, which value occurs most often? And we look through 8, 6, 4, etc., and we realize, all of the values only occur once. So there's really no single value that sort of stood out to be more common or more frequently occurring than any other value. And so you'll notice there for variable z, I say mode equals, and I just have a question marks. Because of that, there's a shortcoming to the mode. If there's not one most frequently occurring value or group, it's hard to compute a mode. A similar situation occurs with variable w. When we look at variable w and try to compute the mode, we notice that two of the values, 1 and 3, both occur twice, or the most frequently. So do we say that we have two modes? And a technical term for that would be bimodal. And we'll talk more about that later. But do we say we have two modes, 1 and 3, or do we pick one, or what do we do? So that's going to throw some confusion in. And remember, and you'll see this with the disadvantages of mode, a tough thing we have to remember with statistics, by definition, a statistic is a single number. So as we can see with this, if I'm trying to compute a mode, a single number, for variables z and w, I would have a hard time coming up with one number to represent the mode. That's going to become a disadvantage of the mode. So before I jump too far ahead, let's look at the advantage and disadvantages of using the mode. So the best advantage for the mode is that it's good for both nominal and ordinal level data. So in a nutshell, the mode is sort of your gold standard or your go-to measure of central tendency when you are working with qualitative variables. So I'll say that one more time because that's the big thing. If I have a variable handed to me and I know that it's, especially if it's a nominal level variable, and I look at it and say, what measure of central tendency should I use? The mode is going to be my go-to. Now, if my variable's ordinal, I may choose the mode or I may choose a different one, and we'll see that on the next slide. If my variable is at that quantitative level, that interval ratio level, level of measurement, then I probably am not going to want to use the mode as my primary measure of central tendency. And we'll see some better choices in a few moments. So what are some of the disadvantages of using the mode? Well, first of all, the mode only focuses on the most frequently occurring value. So it's the mode sort of like a popularity vote. The idea that I always think about it is the mode is the idea of, well, if you are not the most popular, we ignore everyone else, right? It only pays attention to the most popular number, the most popular group. And in that case, it ignores a lot of the other data. That's a shortcoming of a statistic. By definition, once again, a statistic is supposed to describe some aspect of a variable. Well, if we're ignoring a good percentage of the observations, we're not using all the available data. A second disadvantage of using the mode is one of the things we stumbled upon when we looked at variables z and w, is that it's possible to have multiple modes. You may have a tie for first place, in other words, for the most frequently occurring value. And therefore, if you have multiple modes, you're losing precision. You're losing that single number aspect of a statistic. Okay, let's move on to the second measure of central tendency. The second measure of central tendency or location is the median. So we're kind of marching up the ladder here. The median, by definition, is the middle value in a set of data. So now it's not like the mode where it only focused on the most popular. Now it's looking for who's in the middle, right? That's sort of the focus of the median. So now the variable we're thinking about, how do I figure out the middle? Well, we're going to have to be able to rank our values in numerical order. So already you might start thinking, okay, nominal level variables, the median probably is not going to be a good choice because nominal variables, you can't even rank them in order to figure out what the middle value might be. But our other levels of measurement, ordinal as well as interval ratio, maybe we might want to choose the median. So before we get too far, let's talk about computing it. So since the median is the middle value in a set of data, the first thing we need to do is take all the observations and rank them in numerical order. So if we look at variable x and we take those 6 observations of variable x and put them in numerical order, what we have going from smallest to largest is 3, and then 2 observations of 4, and then a 5, and then a 6, and then an 8. So we have the 6 observations laid out in numerical order. In order to compute the median, I need to find the middle of that number list. So since I have an even number of values, I need to find the halfway point, which is right between those that 4 and that 5 in the middle of that number list, and then figure out what is the numerical value that is halfway between 4 and 5. So I can add them up. 4 plus 5 is 9, divided by 2 equals 4.5. Or if it's pretty clear like this one is, I can just look at what's halfway between 4 and 5, and most of us are going to go, it's 4.5. So for this one, for variable x, the median would be 4.5. Now, if I had, say, 5 observations, or 7 observations, or 9, or some odd number of observations, computing the median is actually even easier. I do exactly what I did with this example, where I take all the values and put them into numerical order, and then I find the middle value. And if I have an odd number of observations, that middle value is going to be a standalone number, and that equals my median. Okay, so for variable x, we got a median of 4.5. Now let's look at variable z. And this is going to illustrate a particular advantage of the median that we'll see on the next slide. Variable z, you may recall, is a parallel version of variable x, except for one change to it. And that is the introduction of an extreme value or an outlier. So variable z, you may recall, if you look at case number 6, we see that outlier, that value of 28 instead of the value of 4 that we saw for variable x. Introducing that outlier of 28, what does that do to the median? Well, let's take a look. At the bottom of this slide, we see variable z, how to compute the median. Once again, we rank all the values in numerical order. We go to the 2 middle values because there's an even number of observations. That's 5 and 6. And then we go halfway between 5 and 6, and we get a median of 5.5. So by introducing even a single extreme value or outlier, we see that the median was influenced. You notice for variable x, it was 4.5, but with the introduction of an outlier, it went up just a little bit to 5.5. Now you may go, well, that seems like quite a bit. Trust me, that's not that much of a bump, as we will see in a few moments. So this is going to illustrate that only that 1 point of difference, that a huge outlier moved the median, is something that we're going to talk a little bit more about on the next page. So the median only changed from a 4.5 to a 5.5. Let's talk a little bit more about that, as well as some other advantages and disadvantages. So the advantages for using the median. Well, first off is that the median is useful over quite a few levels of measurement. You'll notice we started off talking about 4 levels of measurement in this course: nominal, ordinal, interval, ratio. We then collapsed interval and ratio into just sort of like one category. So we now have nominal, ordinal, and then interval ratio. Well, the median can be used for 2 of those 3 categories, both ordinal as well as interval ratio variables. As long as a variable has rank, you can use the median. So that's one of the useful things. It's for a variety of levels of measurement. Second, and this is what we saw with the comparison on the previous slide between the median for variable x and the median for variable z. And that is that the median is very resistant to those extreme values or those outliers. So when we have extreme values, as we see with variable z, the median is a good choice to use because it's not heavily pulled or influenced or biased by those extreme values. So, and this isn't something that's all that uncommon. A lot of things that we see in the real world in data collection and read about and hear all the time in the news media, we would want to use the median as the quote unquote average value. So when we talk about salaries that people make, right? There may be a lot of people make between $15,000 to $85,000 a year, But then there's those outliers. There's those people who make $5 million or $10 million or $20 million a year. There's not a lot of them, but they can skew sort of the distribution. Home prices and values, similar idea. You have those mansions on the hill that can skew the distribution. When we're working with offenders, one of the things we often measure is number of prior arrests. And even people who have a decent criminal background usually only have a handful or maybe a couple dozen total arrests in their lifetime. But there are some of those chronic criminals who may have several hundred arrests. They are outliers. And when we're trying to figure out, well, what's the average number of prior arrests or the average salary, this is where the median may come into play as a useful measure of central tendency. But there are still disadvantages to using the median. One is similar to what we saw with the mode, the median also ignores a lot of the data. Whereas the mode was all what I said, it was all about popularity, right? The most common, the most popular one to show up gets all the attention. Well, the median is kind of like its focus is on teach to the middle. What is the middle of the class, so to speak? And therefore it ignores, if you think about ranking values, it ignores those values are at the low end, it ignores the values at the high end, and it's only focusing on the middle rank. So it's ignoring a lot of data. And then also it's not useful for primarily nominal data. And I mentioned this before. You don't want to use the median for nominal variables because there's no rank to those. The numbers are completely arbitrary. Okay, let's go ahead and move on to our final measure of central tendency and location for this lecture and see how it compares to the mode versus the median. So the mean. Most of us are, even if we had never taken a statistics course, have heard of the mean before. And this is sort of our granddaddy of measures of central tendency, but even the mean has disadvantages. So let's talk about how to compute it, as well as the advantages and disadvantages of this particular measure. So what is the mean? Well, the mean by definition is the arithmetic average or the mathematical balance point for a set of data. So already within there, one of the key things about the mean, it's all about math. So as you're going to see on the next slide, the mean is sort of your gold standard for quantitative level variables. It's your go-to in that case. It is very math driven. It even has the fanciest statistical formula, as you can see in this next thing I'm going to talk about, compared to our other measures of central tendency. So the mean's carries a lot of weight with it. Well, how do we compute the mean? Well, let's take a look at variable x. So our first bullet point examples, I say formula. And here is that good old-fashioned summation notation format for the statistical formula for the mean. And so going back to symbols, also from a prior lecture. Remember, the symbol for the sample mean is a variable with a line over the top of it. So we see that x with a bar over it, so we often call it x bar. And it equals the sum of all the values of x divided by the sample size. And many of you, even without looking at summation notation, if I said, here's data, please compute the mean, in your mind, you just know, okay, I compute the mean by I add up all the values and then I divide by how many there were. That's what it is in that summation notation formula right there. So even though a lot of things, cool things about statistics is we kind of know how to intuitively work with them, or we've been taught them in a different way. So that's kind of the fun part of bringing it all together with a class like this. So let's get back into computing the mean for variable x. So first of all, I need to sum up all the x values in the numerator of my formula. So I have 8 plus 6 plus 4 plus 5 plus 3 plus 4, which gives me a value of 30. And then I need to divide by the sample size, which was 6. 30 divided by 6, and I get a mean of 5. Now, we think about interpreting and the value of the mean. And that mean of 5, if we look at variable x and those distribution of scores we see there from the 8 all the way down to the 3, and we say, does 5 sort of seem as a good balance point or sort of representation of sort of the typical average response amongst this range of values? And I think many of us would say yes, right? we've got a mean of 5, which is exactly equal to one of the cases. There's a couple cases or 3 cases that are only 1 point away, and then the other cases are only 2 or 3 points away from the mean. So that value of 5 looks like a good, solid representation of the central tendency of this variable x. But let's see what happens to the mean when we introduce even a single outlier or extreme value. So let's shift our focus over to variable z. Variable z, as we know from prior slides, looks a lot like variable x, except for case number 6. Case number 6 is that outlier with a value of 28. Simply by introducing that person, let's see how much it impacts the mean. So in the purple, we see that now we're dealing with z, so z bar meaning the mean of z. So we sum up all the values of z, divide by the sample size of 6. So we add them up, we get a sum of 54 divided by 6. And sure enough, now the mean for variable z is 9. Think about that. Now let's compare the mean for x versus z. That single outlier almost doubled the value of the mean. That's going to become a disadvantage for the mean. And you contrast that back with the median. Remember, the median was resistant to that outlier, and that was one of the good things for it. This is sort of the Achilles heel for the mean, is that it is not resistant to outliers. And we ask the same question as I did with variable x. Look at variable z. Look at those observations. Does 9 seem like a good sort of spokesperson for the central tendency of that variable? No, right? The first 5 observations are all below the mean, and then the final observation isn't just above the mean, it's like 3 times bigger than the mean. So we sort of get that idea that 9 does not seem as a good representation of central tendency. And finally, as we wrap up this lecture, let's talk about some of the advantages and disadvantages of the mean. Some of these things I've already alluded to. So first of all, the biggest advantage all around for the mean is that unlike our other measures of central tendency, it in fact uses all the information available. Every single person got a vote. The 8 contributed, the 6, the 4, everybody contributed. And so when I think about the mean and its examples, I think about it as being sort of the most democratic of the measures of central tendency. So that is where it sort of comes into play and also makes it a very strong statistic. And in fact, it is the gold standard for quantitative variables. Why is it considered the gold standard for quantitative variables? Well, as you will see very shortly in this class, it's used in a whole lot of statistical computations and formulas. Even as we're still working with descriptive statistics, other descriptive statistics like the standard deviation relies upon the mean. And then within inferential statistics, a lot of our focus is on comparing the means of different groups. So the mean runs through all forms of statistics and all levels of statistics. So that's why it's become the gold standard. However, even though it's the gold standard, the mean still has a couple disadvantages. First, and this is what we saw illustrated on the previous slide, is that the mean is very sensitive to extreme values. In fact, the mean tends to be pulled toward outliers or pulled towards extreme values. And that's what we saw, right? When we looked at variable x with a pretty even distribution, the mean sort of fell right in the middle, a value of 5. It wasn't pulled in one direction. However, when we computed it for variable z, with that single outlier, that high value of 28, it pulled the mean towards it. So the mean got much higher and was pulled in the direction of that outlier. And instead of having a value of 5, it became a value of 9. And so that makes it sometimes to be a misleading measure of central tendency. And when you have those extreme values or highly skewed data, that's where you oftentimes want to consider the use of the median. Now, when exactly to draw the line between choosing the median versus the mean, we will talk more about when we get to the third component, which is shape and distribution, in a couple of lectures. Finally, one last disadvantage of the mean is because it is so mathematically driven, it's not useful at all for qualitative data. So if you're working with variables that are at the nominal or ordinal level of measurement, you don't even want to consider the mean. If you're working with nominal level variables, you're looking to use the mode. If you're looking at ordinal level variables, you're looking at either the median or the mode. Once you get up to interval ratio level variables, now we start considering the mean. Unless we have a problem with outliers or extreme values, then we fall back to using the median. And I know I kind of went through those last little points, like that summary, kind of quickly, but as you go through this, take a moment to think back and think, if I was given an illustration or handed a variable and it was at a certain level of measurement and it showed certain characteristics, what would be the best measure of central tendency that I would choose to report in order to summarize that aspect of that variable? All right. In our next lecture, we will turn the corner and go to step 2, which is talking about measures of variability or dispersion, and I'll see you there. Take care.